welcome to another fantastic lesson on logs. My name is Miss Kreppel, and I'm going to be reviewing with you guys today log properties. So I hope that you guys are not as afraid of logs as you were in the past, because they're not really that big of a deal, and now that we've been practicing them for a couple days, you should be thinking, wow, logs are really a lot easier than I thought. So don't stress, logs are fun and we use them every day. I do anyway. So the log properties that are really important, we can break them up into three groups. We have the power rule, the product rule, and the quotient rule. So the power rule is really probably my favorite one. If I have log of any base, like, so maybe base n of b to some power, the thing that's really important about this, the whole reason why logs were invented, this whole reason that the power rule says that you can bring that power right in front of the log. So that would just be x log base n of b. And this works for natural logs, logs of any base, all the time. So this is super, 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 super important. Don't ever forget it, otherwise your life will be over. Okay? The product rule, just like it sounds, has to do with products. So if I'm taking two things and I'm multiplying them together, I can separate those two logs by just saying it's going to be the log of x plus the log of y. And now I can work this way and stretch it out, or I can start this way and shrink it down and work in that direction. And then the quotient rule, just like it sounds, quotient, of course, that sounds exactly like divide. That's why we use the word quotient, because it means divide. I don't know why. So let's see, log of x minus log of y. So if I'm dividing something here, all I have to do is subtract. So you're going to see problems like this in your homework. Rewrite in expanded form. Now this is just really fun for you guys to practice, like using your log properties, but you're never going to see logs and say, oh, let's stretch that out to be super long. We're most of the time going to be working in the opposite direction of shrinking them down so that you can solve them. So here's an example. If I have log of the square root of xy divided by z to the fourth. Let's say I have something like that. So the first thing that I would want to do is I'm going to write it as, I'm going to separate these because this is division right here, so I'm going to rewrite that as subtraction. So I'm going to say this is really equal to the log of the square root of xy minus the log of z to the fourth. Now remember, square root is really the same thing as 1/2 power. And because I'm square rooting x and y, these are really both log x to the 1/2 power times y to the 1/2 power minus log z to the fourth. Okay? Now here, because I'm multiplying these two together, I can use the product rule, and instead of multiplying, just write them as two logs stretched out. So I'm going to write it as log of x to the 1/2 plus log of y to the 1/2 minus log of z to the fourth. And then the last thing that I want to do is just bring all the powers down in front. So the 1/2 can come down, so I end up with 1/2 log x plus 1/2 log y minus 4 log z. And that would be your final answer. Now, not very practical. Like, I started off with this nice compact statement, and then I ended up with something like this. So let's work on going the opposite, and let's condense. This is going to be more useful for us anyway, because we're going to be condensing things in order to solve. So when you're solving, oh, let's do natural log. I like natural logs anyway. Natural like my hair. So let's say 4 natural log of x plus 2 natural log y minus 4 log ln z plus 2 ln w. So the first thing that I'm going to want to do with this is bring all the powers up top. So that's using the product rule in the reverse. So this is really the natural log of x to the fourth plus the natural log of y squared minus the natural log of z to the fourth plus the natural log of w squared. Now everything that's being added here, I can shrink up into one log by saying, oh, if I'm adding all of these logs, it's really just the same thing as multiply. So it's the natural log of x to the fourth times y squared times w squared minus the natural log of z to the fourth. So I just moved this addition piece over there so I could multiply. And then because I'm subtracting here, all I have to do is write it in one big natural log, x to the fourth, y squared, w squared over z to the fourth. Something like that. So that's really it for log properties. You're going to have more problems that you're going to be practicing in class, but you don't need to listen to me talking forever about these things. And then you just have one other quick thing that requires a calculator. And yes, you can use your calculators in class today or tomorrow or whenever it is that you see your teacher next. And it's called change of base. All right, so most calculators only will evaluate logs if they're natural logs, so base E or base 10, LOG, log base 10. So what if you have something like log base 5 of, 25? Well, this one we can do without a calculator. So I just do this, log base 5 of 5 squared, and then since those two 5s are the same, I know that's just equal to 2. Easy. But what happens if I end up with a number over here that I can't rewrite in terms of the same base? So let's say I have log base 5 of 100. Oh my gosh, I can't rewrite 100 as a power of 5, so I'm kind of done. So I'm going to use the change of base. So the change of base says all I have to do is write it as log of 100 divided by the log of 5. And basically now I'm changing it to base 10. Or you could use it in natural log. So you could say the natural log of 100 divided by the natural log of 5. And if you pick up a calculator and you just type those into the calculator, if you do log or if you do natural log, you will end up with the same answer. So why don't you type that into your calculator and figure it out, and then you can practice more of these in class tomorrow. Okay, sorry the video was so short. I don't want to hear any tears tomorrow. Oh, Ms. Grapple, please make the videos longer. See you later.